All right, we are live for day 10 of Advent of Code. And good news, my I think my cough is finally starting to go away. So we can have a a decent voice tonight. Okay, so we're 30 minutes away. Let's think there's not much to there's not much to review here. This is a disappointing. It was an easy problem. Still fun, but I it's like a day 1 problem, right? Not quite day 10, day 9. Anyway, I was thinking about warming up on day 10 from a previous year, in particular last year's. This is an interpreter problem. Um, but I might also check in what people have to say about this problem. Uh, I think I think there is a direct closed form for this. So I think you can actually just do this with straight up math instead of doing it algorithmically. As like my solution is one of those. Basically, I take I have this for calculating all the deltas. I get all those lists of deltas until we have a 0, and we just take the last element of each line of deltas and take the sum. It's that simple. And then for part 2, we just reverse before getting the predictions. Mm. Um, yeah. And there is some math behind this. This has names. That's what they're talking about in the Scala Discord. Maybe I'll rename these when I learn what the names for these things that are happening are. This method, finite differences. A finite difference, it's called a difference table. Special case of a more general method called Lagrange interpolation. So we could learn about those. That might be interesting. I'm certainly curious. And Seth wrote today's article. Um, so I might just see what he says in that article. Has this merged? This is not yet merged. So let's look at it. Um, hmm, Method. Okay. He points out the links. Can I? Link's not clickable in a pull request. That's just a little bit annoying. Okay, let's click on it from here. So finite differences. Visit that site. Oh boy, that's bright. I'm sorry. Let's turn it down. And then we have a difference table. Also visit that. And Lagrange interpolation. Okay, so I was gonna warm up. Now we're falling into a little bit of a rabbit hole. A finite difference is discrete analog of. Okay, yes, it is kind of like derivative. That's exactly true. We're getting all the deltas, but now it's discrete. It's just per integer or per element of the sequence. And essentially, we're calculating the derivatives until we get all the way to 0, right? I totally saw that. The forward finite difference. Yes, yes, yes. But what was it used for? The nth power has a constant nth difference. For example, take 10. Okay, it's just telling us how to compute. Finite differences lead to difference equations. Um, let's look at what difference equations are, which are finite analogs of differential equations. Okay, interesting. So we're doing finite discrete calculus. Table made by subtracting adjacent entries. Okay. Let's see, what did I call that? That was like my deltas, right? So this whole thing is the difference table, right? And then deltas. Uh, and these are the final deltas. I should call them last deltas, right? Because it's always like the last element, last deltas. Let's keep that in line with this. And then here's a line of deltas. or it's like the previous line, which might not necessarily have been deltas. The first line has not of deltas. Mm, okay. I mean, let's call it row instead. These are rows of a table, right? Maxim, hi. Welcome to the channel. Oh, and welcome over from YouTube. It's good to see people finding me over there. I take it you're doing Advent of Code. Um, so that's a difference table. And Lagrange interpolating polynomial. So right now, what I'm doing is I'm looking up some of the math from yesterday's. So like this is how you solve it normally. Just algorithmically doing what it says in the problem. Pretty straightforward, but apparently there's some math behind this, and you could probably get a closed form for this. So that instead of being order n, it's just a computation on the numbers in that row. Um, I am not sure yet. Lagrange interpolating polynomial. That passes through the points. Okay, it's the polynomial that passes through all of those points, the zeros that you give it, or just any point altogether. Okay. They are used in fancy stuff. Okay, this is cool. None of this is really directly relevant to me, though. Yeah, I read this in an article by Seth Tissue, who's writing a little bit about today's problem. At the Scala Center, there are several of us taking turns. My day will be day 11 to write an article. I think I took up 11, 17, and I forget the other day, but it's also prime number, maybe 22. Um, this method. Okay. Anyway, this method for whatever we were doing yesterday, it has a name. It also gives its name to Charles Babbage's difference engine. That's interesting. The method just to be straightforward. Okay, so this is the core logic. I don't think I really need to go over this. Using lazy zip is good. I just used a normal zip myself. These zip the values with their tail. And of course, lots of people probably use sliding. In fact, Copilot first autopiloted to sliding, but it's you do have to like do a pattern match of the seek type. Okay, parsing is also straightforward. Part one, and extrapolate. Where's our extrapolate method? Yeah. So here, if it's all head, then x is at head. Otherwise, x is dot last. And then extrapolate recursively. This is not tail recursive though. One advantage of using a built-in method like unfold or fold is it will automatically be tail recursive, so to speak. Right? It's the same structure you would have. You'd have to rewrite this with an accumulator. And in this case, your accumulator is sort of this state that you keep passing along. Similarly with the fold, like the fold version of the Taylor recursive version of a function is going to look more similar to whatever you'd pass to a fold or an unfold. In fact, technically, I think this could have been done with a fold too. Could it have been? No, it could not have been, because you're starting with one value, which is a vector, and then you're creating many more values, so it has to be an unfold. Yeah, so I think that's enough of that, unless there's more being said in the Discord about this, because I know someone did have. Okay, yes, here is a math solution. Wait, hold on. Big decimal. Wait, they are just getting the differences. Xi minus j. What are I and j? I and j are indices. Xi is a value at x. Um, Lagrange interpolate. Wait, is it the X? Okay, how's this being called? Input.map, Lagrange interpolate. Oh, um, okay, there's all the data. And then this gives us a function that we map over all the data. Uh, oh, wait. These are okay, these are partially applied functions. So you apply these to an int. Result one is you take each of these, so lengths, input.map length. Okay, you take all the lengths, polynomials, you zip them with the length. So these are polynomials for each function. And this function then, this polynomial, when applied, okay, but what are we doing with the data? So the data, big decimal data I, see, this is a case where I, I, I do wish they just written like zip with index var. Is there a need for a var? Is this even reassigned? Okay, term equals term times xi minus j and I minus j. That being indices, xi. Okay, well, I'm not quite understanding this, but this is clearly different. I think it can be written with more clarity too. J, so if the indices aren't the same, xi minus j, I minus j, so the delta, or the divided by the difference in the indices, and xi, again, these ints, the polynomials are being applied, they're zipped with the lengths. Oh, they're being applied to the lengths. The xi is the length, so the order of the polynomial, rather. Okay, so order minus, and we do that for every I, and result plus equals that term. Interesting. I would have to print this out piece by piece to understand what it's doing. I wonder. I'll ask him to explain it further. Okay. Yeah, and we will leave it up. We will leave it at that. And where was I? I was going to do a warm up. This is a 15 minutes. I don't have 15 minutes to do a day 10 level warm up. I don't know. Let's look at. Can you give an overview of your range interval functions? I want to build my own. Oh, yes. Yeah, absolutely. Um, let's do that. So that was from day 5, just 2023. And they're not in here anymore. They are in point. Okay. So here we go. So an interval, this is a case class with a min and a max. And I don't know what language you're doing this in, but I build everything around min and max. And then n here is just my integral type. This works with any long, big decimal, int, whatever you want. You're doing this in Java. Okay. Yeah, so you could write something like this. I have methods like that make it look like a collection, right? So the size of this collection contains, in this case, it'd just be like check if n is between those two, right? You don't have to check every element of the collection. This converts it to the base Scala range, um, etc. And then we start getting to interesting stuff here now when we get to like superset of. So this is a function. Um, this looks like something you might get on a set method, or a method you might get on a set, right? And I look at that under the interval, make sure like our min is between that and our max is between that. I mention this only because it's going to be used in intersect. So there are four cases here, right? So this R, this other interval, if we are a superset of it, then the intersection of these two is just this middle, is just R itself. And if R contains the minimum of our interval, then we know that R overlaps it to the left. And we know that it doesn't overlap to the right because that case is covered by this one when it's a superset. So when it overlaps to the left, then we have a lower max now, which is going to be r dot max. So this copy method here means we're just copying our current intervals, which means we keep the same min. So when we're intersecting to the left, we're keeping the same min. When we're intersecting to the right, we're keeping the same max. And min is determined based on, the max of the two mins. Here is the min of the two maxes. And otherwise, they don't overlap at all, and we give a none. And then it's similar logic for diff. I mean, I think it's a useful exercise to think about this kind of stuff on your own. The one difference with diff, the one thing that makes it tricky is you might have the case where this other interval is inside of your current interval, in which case you get split into two intervals, right? And then in other cases, you just subtract the parts that overlap. How to put is connected and new range, max starts, min ends for intersection front. Um, hmm. Is connected. I suppose, yeah, is connected would be useful, right? That just tells you, do these two overlap? And you could just say either this range contains the min or max of the other, or the other range contains the min or max of this one. New range, max starts and min ends. I'm not sure about that. I'm not sure what that would mean exactly. The maximum of all the starts. Oh, okay. So what you're thinking there is like a union. And that almost works. I would be careful of the case where maybe you have two ranges that aren't even overlapping. And if you took the min of the, which pinky is it? If you took like the min of the lower range and the max of the larger range, then you're going to say a bigger range than actually is, because there's going to be a gap there. So a union is a case where you might end up with a list of intervals. And that's where these get tricky. And I think I did play around with the idea once of having a superclass of this that just represents sets of numbers in the fewest possible number of ranges. And like maybe calling it like a range set or something. That way, when you do take the union or intersection of something, instead of getting a list of interval, you can return something of the same type, which is this set of ranges. But for now, I just have the range on itself. And if you take the union or you take the intersection, you might get multiple ranges. But yes, union does come in handy. I think I used it in day 22 of 2021, and that code is not copied over here because that does get a little bit more complicated. Let me see. Day 22, 2021. Is there a union here? Okay, I didn't quite take the union. I just took the computed size of the union. And to do that, I So I did, excuse me, I did a lot of diffs. So I sorted them by size for like efficiency, and then I kept like diffing everything. So my union is a list of ranges, and then the new piece, I would diff all the existing union ranges against it to like remove all the overlaps. And then I would add that new piece. Once all the overlaps are removed from it, I'd add that to my set. And then I'd do that on down the line of all the things I was adding to the union. Take off all the overlaps and then add it to the set. Um, this flat map diff. Yeah, yeah, no problem. It's a fun exercise to do, and it might come in handy later this year or in another advent of code. But someday uh, I'll make the full range set class that this is a subset of. Oh wait, there's a name for this. I think there's a name for this kind of thing, and I looked it up. I had a Wikipedia tab. Um, and honestly, there might already be other implementations of this in Scala, but I think for advent of code, I want to use things I've implemented myself. Yeah, but it does prevent you from working with, you know, vectors of indices. I thought today would be the day this cough is over. I've had this cough for like 3 weeks now. I was sick nearly a month ago, and I'm still coughing. So we we put on another cough drop before we start. I could keep working on something in my library. I have to-dos here. We haven't really had a grid problem yet this year. If I started work on this, it might come in handy. This to-do, we want our set map grids and a 2D grid of some sort. So a grid based on sets and maps. Right, so we might have a class grid that has a type of element in it. And then the elements. So it has an area, and it has elements represented by a map of points to T, whatever that is. Right. But then at this point, I don't know. It might suffice to have these be just separate things. I might just work with the map itself. Like sometimes it's easier to work with a map than it is to work with a hash map than it is to work with a 2D array. Especially in the case where you're changing sizes, and also in the case where it's sparse anyway, it's going to be more performant. I think I use a map of points or a set of points even more often than I do use a 2D array. But I'm not sure I want to do that yet. I think after maybe I run into a problem, then I'll think about how that applies. This code, by the way, is all right here on GitHub. I'll put that up there. And if you're looking from YouTube, you can just click in the description and see that. Okay, we will leave that for now. I don't think I want to get too invested in a warm-up problem. I will just uh, we browse the leaderboards. So yesterday I was slow. I had some like train malfunctions too. Um, was I debugging something? I think I was. I think I was debugging something silly. Oh, 8, I was debugging something silly. Like I had a test input that I forgot about. Is this enough for parsing a line of nums? Um, line dot split, and with that, uh, okay. So I think that's a little bit overkill. So this will not match any of the integers or any of the minus signs. And it will split on the spaces. I think all you need to do in this case really is split on the spaces. Yeah, just splitting on the spaces is enough. And you don't even need to parse the numbers because this here will happen. Now, what might happen there if you do have just a space is it will split a string like this. So 3 space space 4. It will make a space here and it'll make a space here. And then you'll get an empty string in the middle. And so when you try to turn that into a long, then it will fail. And similarly, even if there's just one space in the front, it's going to count that, and then you're going to lead off with a line. So what I would do is I take this, and then I would trim it. And if you're confident there, and then you could do like space plus if you want, or slash W, whatever the white space thing is. And then at this point, you split by space or space plus, right? And then that map dot to int, and then that should work. Not to list, you can see it. So list 3, 4, right? And that will break when you have 2 spaces, and at that point you just do the plus, and then you get the 3, 4. Ready for day 10? Yes, yes, I am. Eric Wassel. I am ready. I am more than ready. Will it be harder than day 9? Not gonna lie, I thought day 9 was a day 1 problem. But I see the wisdom in putting a day 1 problem that ChatGPT will struggle with. I did check day 9 after the fact, and it had no problem with that. But I think the first 3 days, ChatGPT struggled with solving those. And I think that's a good way to start us off. No one expects it to suddenly work on day 9, right? As you always are. No, I'm excited. I'm excited. I feel like today is the day I get some redemption. I will read the problem. I will not spend too much time reading it. And I will check myself as I go. Oh, you don't know? Okay. Yeah, I thought for sure it was intentional that day 1 was something ChatGPT couldn't solve. Because it seemed harder than past day 1s, and it was an issue last year. But I guess then it's a lucky thing. Yeah, that was my theory. Oh wait. I need to start a new file. Day 10. I'm not ready for day 10. I need to do this. You have 16 seconds. Okay. Change this. And our input is going to download. Great. We are ready. Okay. Asking nicely. Fair enough. Day 10. And here's, ooh, look at this. What is this input? There's a lot of F's. JLFJ. I think we have an interpreter problem today. That's fun. Ooh, it's a maze. Type maze. These are tiles. F is a 90-degree bend. Okay. We have bends. We have a pipe map. Oh, I think what I need to do here is stretch this out so I can see it. There we go. It's a pipe map. Okay. The pipe that contains the animal is one large continuous loop. Here's a square loop of pipe. Okay. If the animal had entered, so there's an animal somewhere in this. I don't know the backstory here yet. I just want to know the question, which is find a single giant loop starting at S. How many steps does a loop along the loop does it take to get from the start position to the point farthest from the start position? Uh, steps along the loop does it take to get from the starting position to the point farthest from the starting position? Farthest, I guess, Manhattan distance. Let's see. Let's see. Okay, so this is going to be a grid. Um, and you know what? Import AOC dot star. I'm going to pull out area here. So area of grid. Wait, interesting that I thought to do asteroids first. Area of grid. Okay, so it's 140 by 140. And we'll do something with the points at some sort. You wander around for a while, you don't find any people. Landscape is alien. Scanning the area, you discover entire field. Same metallic silver colors ground. We sketch it. Vertical, horizontal, 90-degree bends of various types. That's just ground. S is a starting position. Okay. Dot find. We need to find a point such that grid of that equals S. So this is the start. Val start. Val area. We'll just give that a name. Okay. So our starting point is 5158. Based on the acoustics of the animal scurrying, you're confident the pipe that contains the animal. Wait, so what about the animal here? Can't find any people or animals. Look like an animal. You notice something metallic scurrying away. Okay, we want to find this thing. If the animal had entered this loop in the northwest corner, sketched it instead look like this. Okay, in the above diagram, that's okay. So we just look for things that we just flood fill from start. Find the loop. Unfortunately, there also aren't many pipes that aren't connected to the loop. There are also many pipes that aren't. Okay. Okay, so let's just get a list of all the points that are connected. Val connected or def connected. And then from some point, so it's starting point. And we'll just use the grid, and then just going to return a set of points. And we're going to iterator.unfold. So we start with a set of points or an empty set of points. So set that empty point, and then we have set of our start. And we have these names. So this is case, scene to visit. I usually like to call them visited and current. Yeah. And then option, not when, current is non-empty. We continue searching. Okay, and then next equals current.flatmap area.adjacent. Is it adjacent defined within area? I suppose it is. No, it's in point. It's point.adjacent. Okay. The, the current is a set of points. We're going to flat map adjacent and filter not visited. Yep. Adjacent. Yep, filter not visited. And then we do another filter on top of this. So we're going to diff visited, flat map adjacent, diff visited, and then we're going to diff if it's possible to go there. So def, we have to use our own adjacent method. Def adjacent possible. I guess we just write our own adjacent function. Adjacent. And we're not going to use that. So we look at the north points separately, etc. So p dot n. So grid in p dot n. So this gets included if it contains a contains that or a 7 or an F. Yeah. And then we do similar stuff for all of these. So I'll just make these like options. Option dot when, and this will be grid dot north. Grid p dot n, and that element is contained, or rather, these three elements. So 7, pipe, and F contains the element that's to the north. Then we return p dot n, val n. Okay. And we do that for south, east, west. And then we do a list of north, south, east, west, flatten, to set. Exactly. Okay, so south, now we have J and we have L. And then east, going to the right, this becomes a dash. And I suppose 7 still works. 7 going down. And what is this? A J that goes up. And then north, south, east, whoops, and west. So we have either an L or an F exactly. And then we have this dash. Okay, so now we replace this adjacent, so we flat map with this our new adjacent method. And then diff visited. And what should we return? We should return current. Current. And this state is wrong. So current becomes our visited. And then next, okay, and then next becomes our current. So val, and then that will be like sorted by its distance already. But if we just flatten to set, actually one of the last ones will be the furthest away. We just want the point that's the furthest away. Oh, okay. We'll just call these step points, and this is an iterator of a set of points. And and 1 equals step point from our start. Drop 39, no. we're gonna do dot to, yeah, okay, two list dot last, or no, actually just the size of this, right? I'm not sure about off by one here. Let me think. So if there were only one other set, we would still return this current set, that'd be 0. So this can be -1. Dot size -1, right? Um, two list dot size -1. We have a -1. Oh, okay, so we have to filter these. Filter um, dot inbounds of the area. Okay. In fact, we can put that filter up here. So dot flatten, and then we further filter inbounds in the area and to set. There we go. We still have a -1 out of bounds. Interesting. Start that end. Let's see where that goes. 51, 57. Right. It decreases. Oh, hold on, hold on. I see what's going on here. We forgot to change these. This is south, east, west. Okay. We're still getting out of bounds. Let's do some smaller tests. So let's look at what's adjacent to the start. And we get 2 points. Let's look at that here. S. Oh boy. Okay, so we can go north and we can go west. Okay, this will be our test. So start.north and start.west. And that should be exactly those two adjacent ones we get. So 5157 and 5058. Okay, so that's some measure of confidence. Where could this be coming from? Yeah, it happens during the adjacent function. Oh, hold on, hold on. So this here, we are already checking grid PN. Grid PN might not even exist in the first place, so we only do that. We should only even do that if it's in bounds. Okay, I'm just gonna do this. Yeah, this is messy, but this gets us there right away. Inbounds area, and then we'll just put an and then we can refactor this later. So p dot north dot south dot east dot west. Bounds with an S. Okay. Yeah, like I should have thought about how to filter that way beforehand. In fact, um, my adjacent method does, I think. Oh, okay. It appears we have some sort of infinite loop, which is weird. This normally doesn't do that on a flood fill. So let's stop this. Let's just start step point from the start. Now P's. And we're just gonna look at that one by one until we find whatever this loop is. So we're gonna P's dot next. The first one should be the start area. And it seems to be looping infinitely just on getting the first one. We're just getting one element. Okay, next is current. We flat map all the adjacent bits, and then we diff out the visited bits. Adjacent seems to work. We can get the adjacent of start, right? And then at that point, we diff out the set 0, right? So this is the code that's happening in there. That diff that dot empty, right? So we should still get the same thing. Oh, wait, things are working now. ps.next, so that's a start. ps.next, and this should be like the north and the west point. And we keep doing that until we find some sort of error. And this is a point at which maybe I should check this test data here. So let's put that in. The day 10, 2023. So I'm going to save this as example. And there we go. The worksheet has not seemed to run yet. Metals evaluated. It's already evaluated. What, is this just empty at this point? Wait, 2 plus 2. Can I evaluate that? It's not evaluating. I don't know. We are just going to start this again. Restart the worksheet. Okay, and we are looking step by step as we progress through here. I should have this done by now. This is just a flood fill. We've done many of these. So in this case, you can go right and down, or rather east and south. And then as interpreting this, okay, oh, we have not changed the input yet. So 51, 57, then we get 52, 57, 50. Okay, I'm not seeing any looping here, right? We're not hitting anything that we've already visited. This seems fine. Okay, I'm just gonna try and get the answer again. And again, when I do that, it starts to be slow. But okay, it seems to be tracing something though. It is tracing a loop. So we are on the right path, right? So 51, 58 goes up to 57, 52. There's only ever one changing in one direction. Interesting that at some point it decides to change into a hash set. At this point, there are 3. And then it cuts off from there. I guess that other one isn't able to continue down any path. It's like it's like a stub. And we just need to know how far the furthest point is, which just means the number of sets returned here. Okay, let's run for a minute. That's too much. Let's do this. Dot take. I don't know. 30. Dot to list. Dot size. I mean, that's just gonna give us 30. But you know, can we get at least 30 elements? That's the question. 60. 90. We'll try each of those. Pending response rejected since stopping server failed. Oh man, I keep killing my server with these infinite loops. Okay, we try again. So we are not triggering an infinite loop. We are limiting to 30, 60, 90. And seeing what we get. Okay, so we were able to go at least 90. I wonder what the 90th element is. So let's take a look at that. At this point, we are, oh, let's drop 90 dot next. Right, we're still at 2 points. Okay. How big is this thing? Area dot size. It's 140 by 140, right? Oh wait, I mean it's that many, but the area itself is 140 by 140. So let's try. If we went around the whole thing as a giant square, that'd be like 280. Let's try 300. So take 300 dot to list dot size. It manages to keep going past 300. Interesting. Let's just do 600 just to have a look. Okay, so what are elements past that starting to look like? So let's say let's drop 450 dot next. Now, once these 2 points meet again, oh, okay, at some point at 450, there are a lot of points that are not connected to the loop. Am I missing something about this problem? By 450, it's no longer just 2 points. I mean, I've written this algorithm enough times. I'm confident this wouldn't accidentally like loop back in on itself. I've already thought that through. Um, so I don't think it's looping back on itself, but rather maybe something else is happening. I mean, we could show that. So here is a set of points. Area dot print. So I have like a show method of some sort. Let's look at size here. Draw. Okay. So area dot draw. So we'll call this val x. And we need the method. So given a point, let's just draw what's there. And in other cases, so if x contains a point, then we draw whatever's there, grid x. Else, we're just going to draw a dot, or a space rather. Let's see what that looks like. Oh, I don't know, p, if x dot contains p. Oh, this here, grid p. Okay, there we go. Okay, this is what it looks like at that stage. Okay, let's do this. Val steps equals step point from start, and then take 600.2 vector. And now we can draw various areas, right? So if steps 1 contains P, then we draw it, for example. Okay, so at this point, yeah, that's where we've gone, right? And let's look at 100 steps in. And they've moved further. And let's look at 300. At what point does it start really branching out really heavily? That's what I want to know, because that seems, okay, at 300 is doing that. Let's look at, we're just binary searching this. 200. At 200, there are multiple elements. When does that start happening? So we're gonna do 150. I mean, there's a fast way to do this. I don't need to be looking at this. I can just look at the size of these. So, in fact, what we could do is steps.map dot size for each print line. So it starts reasonably 2, 2, 2, 2, 3, 4, 5, and oh, let's zip this with index. Um, and then dot zip with index for each print line. Okay, so at around, so it starts blowing up around 172. What happens at 172? Actually, you know what? So does start branching out. You want to get, you should find the tile in the loop that's furthest from the starting position, because animal, in my fight, it doesn't make sense to measure this by direct distance. Instead, how that would take the longest number of steps. Yes, that's what I'm measuring, is steps along the loop, regardless of which way it went around the loop the animal went. Right, so 0, 1, 2, 3, 4. That is exactly what I'm doing. And then here's a more complex loop. 0, 1, 2, 3, 4. I could draw that out. No, I can't draw that. How many steps along the loop does it take? Okay. One large continuous loop. We're confident the pipe that contains animals in one large continuous loop. So at 172, that breaks down and we're no longer in one large continuous loop. So I will explore that. At 173. So let's draw 173. So this still has 2 points. Look at 173, 174, etc. We'll do a few of these. Maybe if I do a couple of these, GPT or Copilot will get the point and help me autocomplete. 175. There, that draw. Come on. Come on. There we go. I don't know if waiting for the autocomplete is faster. There we go. There, that. That's enough. Enough. Okay. So at 173, we are, well, where were we at 172? 172, there were also 4 points. As 171 the last time we had 2 points. Or 1 point rather. And also, I'm just going to change these all to dots so it's easier to see the shape of the grid. I'm not seeing where our points are at all. Okay, at this point, I'm going to copy the worksheet output. And we're going to comment out some of those. Copy worksheet output. And we're going to look at this in Scratch. So what did we print? It does not seem to have printed anything. Oh, right, steps is undefined. So steps, here we go. Okay, copy worksheet output. Go back to Scratch. Okay, now we can see these maps in turn. Oh my god, they're so big. So here we go. At 171, we were just here. Oh, we were at these two locations. And what was surrounding them? I guess I could draw them as X's and also draw the rest of the map so I could see what they're turning into. So at this point, 1, 172, then the point over here apparently has 3 next to it. 7, 7, and L. And that's fair. Those all would be surrounding that. And then all 3 of those expand out. Actually, no. No. How does it expand that way, though? Okay, so this seems like it might be a bug. In fact, how could a point be connected to all of those? That's not possible, is it? There's no way for it to be connected to more than one, just given the definitions of our. Let's take a closer look at that. Okay, so we were able to go north to a 7. Oh, hold on. The current point should also matter, shouldn't it? Yes, yes. Okay, okay. Yes, I was treating these like they are one way. So that's it. Hmm. Okay, so we look at the north-south connection, and there are further conditions. So after this contains check, there's another, and we're just going to continue adding these on. So we have another string um, contains the current point. So something that contains grid at this current point, P. Okay, so in order to go north, the current point has to be a pipe up or a J or an L. In order to go south, it needs to be an F, or we can say 7 pipe down, or an F. And then the current point for east needs to be, we are moving east, so we need to have a dash to the east, which is either a 7 or a dash or a J. And if we're moving to the west, it's going to be an L. No, no, no. Hold on. This here is not right. This J is not right. We need to be able, if you're able to move east, it's going to be an L or an F. And if you're able to move west, it's going to be a 7 or a J. Okay, so that should do that now. Unless we have next on an empty iterator, it ends up empty. Oh, because it starts off at start. Start can go in any direction then. So we'll just add S to all of these. Okay, now let's do AND1. And at this point, now there should be, that should be able to move infinitely. 6943. We've got it. We found the bug. 6943. Okay. We might have an off by 1. So let's check that against the example. We are going to eliminate these for now. Maybe I'll leave one commented, just in case I need to do it again. all of these out. Right, in this case, it doesn't go very far at all. 9, the answer is... Oh, hey, thank you for the raid. Trycatch TV. I take it you just finished with this. You were doing an Advent of Code. Hello, hello. Welcome. So I just realized what I just fixed here was not realizing, and also ignore these huge... There's a better way to write this, but I was writing in multi-cursor mode. I realized that I was looking at what I can go to, right, if that's valid, but I wasn't looking at my current point, like, is my current point connected to the one above? And I just realized that, and that's why it was exploding in many directions and not staying in a solid loop. And now I'm just checking about my op1. So I get a 9. You're supposed to get... What is the test? What is the example data? I am using Scala. Anthony Def, welcome. And Happy Toria Def, welcome, welcome, howdy. Okay, so what was the test? 8. Okay, yeah, so there was a -1. I had a -1 written in there earlier. So whatever answer I just provided, I just subtract 1 from it. Oh, let's go back to the main input. I remember thinking about the -1 and getting it right. 6942. 6942. Okay, there's part 1. Okay, you quickly reach the furthest point within the loop. Let me put myself behind here. The animal never emerges. Maybe it nests within the area enclosed by a loop. How many tiles are contained within that loop? Okay, interesting. So this is flood fill from a point that we determine is inside the loop. The loop inside contains merely 4 tiles. Oh no, this is a spoiler for me. So I'm using Python for my AOC. Yes, yes, spoiler warning. Wait, but weren't you just doing Advent of Code in the last stream that you came from? I take it you were not? Let me see. Okay, so here, so we have to determine which way is inside. I mean, we can just do both, do a guess and check. And then find all points. We might need to do multiple flood fills, right? Oh, Nikki, thank you for the lurk. Good to see you. I hope you had fun with today's problem. We were doing a merge for bootcamp validator project. Okay, interesting, interesting. Okay, don't look at the screen. Spoilers. This is kind of cool. I'm liking this. The above loop encloses merely 4 tiles, yada yada. And then all these are not in the loop. In fact, there doesn't even need to be a full tile path to the outside for tiles to be count as outside the loop. Squeezing between pipes is also allowed here, so this is also outside of the loop. Okay, so we determine the curvature and we look inside. I think what we do is we use, excuse me, we use a set of points for the loop, like this whole boundary, and we do flood fill from there. And that will flood outside and that will flood inside, but that will get everything all at once. So we just choose which set of those to continue with, and then we just flood fill. Like part 2, stop me for a bit. Has multiple solutions too. I imagine it does. I imagine it does. Okay, so let's see. Let's get our pipe points, and we can do that. So we don't need any of all of this anymore. We have our step point. This is a weirdly named function. This is like a point stepper. I don't know. So val boundary points equals step point, and then we're gonna reduce this. That reduce with intersect. These are sets. So now this is a set of points. Oh, step point starting from start, of course. Oh no, not intersect. Union rather. Please just yeah, okay. Cool, cool. If you like it, then I'll like it. I like your taste in puzzles. I'll say that. Now here's a large example, yada yada. All of those are outside. Okay, I'm gonna draw my set of points. Ah, yes, and I'll do that. Okay, I have this. So area. Okay, area dot draw. And we're gonna do this function. So P. So if boundary points contains P, then we'll say grid P. Else we just draw a dot, I guess. Yeah. Dot. Okay. Look at this visualization. Oh, um, that wasn't as pretty as I'd hoped it'd be, but we can fix that by pasting it in Scratch. Okay, full screen this. Wow. Okay. So where is our start point? Whoops. We're searching for S. Our start point is here. What's outside? Which way is outside? So we flood fill from here. Diff out the points. And then, I mean, I guess we just flood fill all of these. And whatever is outside. Oh, no, no, no. Parts of these inside might actually also be outside of the loop. Wow. Okay, so that's tricky, right? So these here are not going to be connected to the outside. Maybe we can like determine. Hmm, I mean, they're connected if you can get this path through, right? So we could look for that. Hmm, we could flood fill from the outside, and then we could subtract all the points that are part of the pipes, right? We'd flood fill with like different rules. If like this kind of thing appeared, you had parallel whatever. Except it's not really a set of points anymore. I guess we could look at the points in between. So now instead of these, we have like a different coordinate system, which is, you know, for these boundaries between the points. Then we subtract those outside points. Then we subtract the boundary points. So like if this here, I guess this whole thing, these four, would be one of our points. Yeah, so we're looking at all the corners. And then how do we subtract? We have to subtract, again, the normal points. So we want the size. How many tiles are enclosed by the loop? How many tiles are enclosed by the loop? Hmm. I'm not sure I like that idea of flood filling from the outside. If it's just can tell us the set of points that we should diff against in our first flood fill from here, right? So search for outside points from um and then from here, searching up. That searching up is gonna be a pain. So you have to squeeze through. Yeah, I think we end up translating between coordinate systems. So the corners of the tile corners, and we flood fill tile corners, and then we expand those tile corners into the tiles they're actually connected to, right? But how do we prevent? So we're going to include like this tile corner here, right? And when we do that, when we expand from like this corner here, we're going to include these boundaries, these parts of the pipes, the pipe tiles, or the boundary pipe tiles, which is good. Then we can just subtract all of that. So that's one way to solve it. Do I like that approach? Is that what I'm going to go with? I mean, otherwise it's going to be hard to disambiguate this from this from this. Everything outside, like assuming everything outside is connected, which I think it is. Everything inside is also connected, but determining one of those inside points, right? Like I might start searching from this, assuming it's inside, and try to find what's connected to, but it'll be like, yeah, it's easiest to search from the outside and see what that's connected to. Okay, so tile corners is like a new coordinate system. Tile corners. Um, so it's a new area, and then we have area dot x range. It's not going to be the same x range. Area dot y range. So it's almost the same. We're going to drop right one. Area dot x range dot drop right one. Yeah, that'll work. And same with y range. And then we just have a new corner adjacent function that will determine where we can move from there. Drop right one and drop right one. Okay. Yeah, all corners. And then what we'll get is a set of 4 points. And going back to scratch, um, so we'll start at origin, which will be this first corner between tiles. And we can move anywhere until we hit here, right? And from there, we can move down because of like these rules here. So let's say we have a corner which is these 4, and when we try to move down, we just need to look at these 2 new ones below it, right? First, providing their inbounds. Okay. So corner tiles, I guess, given a point, def corner tiles. given a point, and then this is going to be 4 points. And 1 point will be in the same coordinate system. Yeah. And then of course we can only give this. This is optional. And maybe we'll do point, 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 point. Yeah, it's not gonna be quite these. Option dot when. So the original tiles need to contain this current point. Area dot contains point. Or actually, you know what? The corner area needs to contain this. So corner tiles needs to contain this point. And when it does, then we'll give this point, and then we're just going to go to the right and then down. So p dot e, p dot s, and p dot southeast. Okay. Okay, that works. Wait, corner tiles dot contains. Or tile corners, that's what it's called. Tile corners. Great. And then adjacent corner, I guess. So def adjacent corner. And then this will give a set of points representing corners. B point, sure. And this will be a set of points representing colors, and this is how we're going to do our flood fill right here. So val north. P.n is inbounds of tile corners. Great. And there'll be another condition, and that is that the 2 points north are accessible. Can I give these names? Is that how? Let me just do a real quick test here. So Scala added a feature called name tuples. So def foo. So here's a tup, and then let's say x int and y int. I think that's a syntax. And then we can do x and y, right? No. So we'll return int. No, I don't know how name tuples work. We're not going to do that. We're just going to use our indices. So 1 and 2. Corner tiles of p.n. So they both have to be accessible, which means going north. Like the bottom 2 tiles are tiles that are already part of the corner you're on. Let's look closely at an example here. So let's say we're looking at these 4 tiles, right? We are on this corner. These are part of my current corner. So I need to check that all of these allow me to move up, right? I can move up through there as long as these two aren't blocking me. Oh, so I don't even need to look. So these can be anything, no matter what. So I don't even need to look at those. I just need to look at my two northern boundaries. So we will look at the corner tiles. So we call them northwest, northeast. Yeah, northwest, northeast, southwest, southeast. Okay, and then now our secondary condition here is that the north tiles are some of the walkable ones. So for northwest, we can have what we can have dot. We can have that, have that. We can have anything that has a wall to the left. That will probably block us, right? So J. Okay, so that contains northwest. And a similar string. So here we get L and F contains northeast. And then val south. Wonder if it can figure out how to complete this. Okay, contains southwest. This isn't quite right. It's, in fact, it should be the same. So this should be 7J. And it should also be LF. Right, as long as there are no dashes or anything that are closing in to the wrong direction. Okay, val east. Like if I'd given these semantics, maybe Copilot could autocomplete it. Okay, so this is actually... Okay, if we're moving east, then the northeast can't contain any of those. It can have this, or it can have... Would L work? Yes, because it's not closing down. And J can work. And then similarly, this also has dash LJ. Um, why not 7F? Okay, this is southeast, so we don't want those pointing up. So this is 7F. 7 and F, we want to be flat on the top. Here we want to be flat on the bottom. Here for west, we want to be flat on the left side. Oh wait, we're going west. Yeah, flat on the right side. And here we want to be flat on the left side. Okay, and then let's look at west. Val west equals option not when, yada yada. So this is going northwest. Wait, okay, so we are going east. When we're going east, the northeast point needs to be flat. Oh, hold on, we're going east. We're going to the right. The northeast needs to be flat on its bottom side. The southeast needs to be flat on its top side. Okay. And it's exactly the same logic when you're going west. Right? The northwest and the southwest need to be flat on the bottom and top, respectively. Okay. And then let's flatten those, filter in bounds of the corner tiles. I think we already checked that technically. We don't need to filter again. And then to set, and then now we flood fill. So we're gonna do like an iterator dot iterate. So we have that dot empty of point along with set of, we're gonna do origin, point dot origin. And then we have the visit, and then we get the current, and val next equals current dot flat map. I don't like that code. So we're gonna do current dot flat map edge corner tiles diff visited. But why do you need to do a key set there? Visit is already a set. Oh, hold on, hold on. There we go. So we diff visited. Yep. And then we just return current, and then current and next become the new visited and current. Now outside points, outside corners, corner points rather, outside corner points. It would, oh, okay, what's going on here? Required just a set. That's not quite right. Oh wait, it's not an iterate, this is an unfold. Which means we also have an option. So option dot when current is not empty. Or I suppose next dot not empty. I think current should do it. Yeah, you return current as long as it's not empty. And then at some point, this next will just be like a useless thing. In fact, like this should be, it's going to be defined down in here. Similarly with this code here. Oh yeah, that's how it is done. The next is down there. Okay, so these, we can turn them into one massive set. And then we translate them back to grid tiles, which we can do by translating the whole thing to the right, to the down, east, south, and southeast, and taking the union of all of those. And I think we subtract that. Oh, I should add S to all of these. Should I add S to all of these? Because what is S? So oops, we're searching for S. Okay, so S. So it looks like S in this case is a J. Why don't I just replace S with a J before we do any of this? Yeah. And anywhere there's a J. Okay, all of these contain a J. We'll just put S in there as well. Then that should work. Right. So outside corner points that reduce with union. And then you get a set val. I don't know. I'm running out of names. So S dot union S dot E, and then union S dot S and S dot southeast. And then we subtract those val outside and boundaries equals that big set. Oh wait. S dot union S dot map E. Map E dot map dot south s dot map southeast. So like I'm definitely doing like overcomputation here. That'll be a lot to remove. But now we just do area dot size minus outside and boundaries dot size. Well, adds 2 equals that 19596. How confident am I in this? I am our betting man. I'd say I got this wrong. And I would have won some money. 19596. Okay, so not quite there yet. But what we can do, let's print just this outside and boundaries. Let's do area dot draw p if outside and boundary, then grid p, else we have an inside point. Yes. Oh, you know what? I'm gonna do this. So def right, so point goes to a character. What we're gonna do is draw we're gonna draw the boundary if it's part of the boundary. Right? We were already able to determine the boundary. It's just step points, boundary points right here. Okay. If boundary points contains P, then grid P. Else, if outside boundaries contains P, then we say outside, else we say inside. And then we're just gonna pass this print function to my draw function. Not the best naming, I know, but this is something. This is yeah. Let's copy that worksheet output, go back to Scratch. And what do we get? Oh, we have it backwards. We have it backwards? What? Well, I don't think we have it backwards necessarily. I think we have, it's just that these are the only O points. We didn't get very many O points. Okay. So we did successfully draw the pipes that form part of the thing. And we just called everything else inside. Okay, so we have a slight bug. A slight fixable bug. So what is outside and boundaries size? Outside and boundaries. Apparently this is just 4 outside corner points. So we start at the set of origin. Let's look at what's adjacent to that. Edge corner tiles to 0.00 exactly. Yeah, we got nothing. We got nothing. Oh ho ho ho. Wait. So you can go north if it's in bounds. So south, we can go south. And dot contains, and like any of these. So southwest is a dot. Oh no, not contains southwest, contains the grid. The character in the grid at the southwest point of, yeah. Okay. Grid. Okay, it should look better. It just becomes 6. So this goes to the right. It does not go south. Why? So it goes east. Why would it not go south? Grid southwest. Um, let's do this real quick here. We're gonna test this of point dot origin. So these are the tiles that correspond to the top left corner intersection point between tiles. Okay. And what is in grid at southwest? We should be able to go south. Grid southwest and grid at southeast. These should both be dots, right? Scratch. Let's go to scratch. Oh, let's also just draw the full grid. Draw, and we'll just apply grid. Area to draw. Grid dot apply. Oh, hold on. Yeah, the grid should be able to apply to a point. Point. And let's copy that. Oh, there are not dots in the top left. So the origin point is not part of the outside. What had given me that impression? Yes, the simple fact that it was not part of the boundary. I just, I think when I printed everything here, that was just the boundary parts. Okay. Where are the dots? There are not very many candidates for points here. Be either inside or outside. And here I was wanting to flood fill the outside, thinking like we would reach everything. Like from here, what all can you reach? Not so much. You can go down. And you can't get through this. Okay, so it's not going to capture everything. In this more complicated example that they have here, I suppose I should have that. Okay, so here's this large example. I think I might work on, so it would probably only work on this one right here. I can test that if it works on this example. I mean, of course, I don't want it to be. It would work on this one, right? We'll call this example 2. 10x. X2. And what do we print when we do that? Okay. I mean, it's not even really correct for that one though, is it? Okay, we can draw the grid. It takes the S and kind of runs off with it. it's not able to go south, even though the southwest point shouldn't be in the way. Oh man. And I'm not sure this method would even generalize. Before we go looking into that, let's look at this larger example here. The loop above sketch has many random bits of ground, some of which are in the loop and some of which are outside of it. Maybe I should use another method. Okay, I can see this. So here, they are not all connected. I would have to do multiple flood fills. I mean, again, if we just took the loop itself. Okay, so here when we're drawing, we are able to draw just the loop itself. If we drew just the loop itself, I think I'm back to that expanding from here. The problem is we'll expand in both directions, and we're still not sure how to disambiguate. I mean, that would certainly work. That would work if we could figure out which points don't belong inside. Right, just take all the adjacent points to the set of points belonging to the boundary and keep iterating on that. So this one, how do you find that? I think it's part of the outside if at some point that set of points connects. Well, this is part of the outside here, right? And determining that that connects down here. How many disjoint groups are there? I'm gonna print this again, and I'm just gonna print the spaces. So area dot draw. What's the Unicode for block? Okay, val block Unicode equals, tell me GPT. There we go. Okay, so area dot draw. If so we have a point P, and if grid P equals dot, then we'll just do dot. Else area block Unicode. Okay. Go to Scratch, print that. Yeah. And we'll actually do that with the main test data, or problem input. Copy worksheet out, but go back to Scratch. Okay. So these are all the groups. And now I'm not liking the idea of doing a search from an O, right? Like, okay, we know this is an O. This touches the outside. We could do a search from that to try and reach others of these. I guess we could do a flood fill from all points, and that. So we have a set of like many different points. And then they start like merging together, these sets. And at some point, one of these sets hits a boundary, and then we just remove that whole set. That is not one of our inside points. Um, but then again, we do that, then we have like this point as its own, but we can't start with like every point in its own set. Uh, we could just search from the boundaries and see what points we are reachable. Right, and we take the sets of all. Yeah, yeah, search from the boundaries. We have to search from like all the boundaries. Even so, let's look at a boundary here. Right, the first one starts with like FJ, JF. We can't get in there. Here's a place where we can get in. There's an outside point always guaranteed. Here the tiles are just the tiles are enclosed by the loop. You know, determining enclosed by a loop. If so, all we have to do then. I I don't like this idea of looking for all these outside sets because there might be too many, and then you have to search all the way from the outside. Right, whatever touches the edges. How did we get here? F and J. Mm, which can work. But if we can just figure out which direction. Hmm. As okay, if we take this, we can go. We're not even gonna get two distinct set of points, right? Like we're gonna get this. How do we know that's on the inside? I suppose we could trace the boundary. We could trace the boundary and look in the direction that we think is inside. Like if we choose a point, like choose this one up here and look down just as a frame of reference, and we can do that manually. Um, then we could always say like, okay, let's follow the path, and we look in clockwise. And if that is not another pipe piece, we add it to our set of points that we consider to be internal. And then we end up with a set of points. Yeah, we end up with a set of points that are internal. We might not end up with all of them, but we'll end up with a subset of them, and they'll be connected to all of the others. And then we just flood fill those until we hit the pipe boundaries. I like that. Okay, so the reason I shied away from that at first was I didn't want to have to like I suppose algorithmically determine which way, right or left, is going to go. Um, and we'd also keep like the left and the right side and just follow a path until we hit S again. So we start at S and we follow a path until we hit S again. And we keep track of what's on the right side and what's on the left side. Right? And that might be empty, that might be a pipe, that might be out of bounds altogether. So I think I'll do that. I'll trace the loop. Honestly, it's what I should have done first, but not that brave. This is seeming more approachable than the shortcuts I'm trying to take. Um, yeah, we're gonna ignore this corner point stuff we were looking at earlier. I'm just gonna comment all of that out. Basically, we're starting over right here. Okay, so we have the boundary points. Let's go to S, and we only have to iterate 7,000 times, right? Um, that's completely approachable. So, def walk. And then we have an accumulator of like left points and right points. So we have current, and how do we keep track of our direction? Um, we have to know where we came from. We have to know where we came from. So the previous point, and we have to arbitrarily choose a direction. And since I know stuff about my input, I know S is on like a J spot. So we're just gonna start with north. Um, so current position, and then direction, which is gonna start at north. And then we have stuff that's been to the left and stuff that's been to the right. And this is going to be a recursive function. This is going to be an unfold. Okay, iterator, unfold. We have state, which is start and direction dot north. And then we also have left points and right points. And those are going to be empty sets of points. Dot empty point. Dot empty point. And yeah, we'll use that. We'll determine which one's outside and inside. I don't know. At this point, like it could also just be a guess. And didn't I mention doing a guess check earlier? Just divide it into two sets and then subtract one or the other. That would work. Okay, so case, we have current, and then we have the direction, and then we have left and then right. Left points and then right points. Or rather, let's call them spaces, because these are going to be empty left spaces. Spaces. Line 3, character 4. Ah, wait. What are you talking about there? Direction. Is the direction I want to move, or is it the direction I just came from? I'll say it's the direction I'm facing, and I'm biased to move forward, or turn right or turn left, but we will never check backwards. Right. Except in the starting J point, if we're facing north, we can go left, and we don't like that. We just want to follow. Okay, so we'll say we're looking north, and then if moving north is like into a 7, then we'll say we're now looking wherever that goes. So the next direction depends on where we go. And I think I might write a separate function for that. So for now, we're gonna write a triple question mark, and then def next dir. Okay, so we are in a position. So given our current position, and then given where we are going, I guess this isn't so hard. Like, so we go move in dir, and then then we match on that. So case, we have to check if it's inbounds. So this is the point that's north. So hmm, yeah. So this is a new position. New position. If grid, okay, like that's correct. Um, this should result in an error, right? There's no way that happens. And this plus, that doesn't even make sense. I don't know where that comes from. There are only really three cases here. There's a 7, in which case we end up facing west, third up west. And then there is the F, which has us facing east. And again, if it says it's the current direction, that is whether we have moved south or we have moved north. Oh, wait. This 7, where we're facing, depends on where we're coming from. Okay, so I suppose we have to match on the current direction as well. Yeah, okay. Let's match with direction as well. How do we do this? Let's do dir and pause. Dir dot move pause. So case should be, so if we're moving north, then we keep going north. And here's a 7, here's the F. Here we end up with west, and then here we end up with east. Okay, and then we have something similar for south. So we have south, and same direction if it's that. What gets us facing west is a J, and east is an L. And yeah, that does indeed get us our next direction. Now, of course, I'll have to do a filter that this is in bounds. Maybe we should do that first in here. I don't know, maybe not quite yet. So do this 2 more times. We have east. So in the dash case, we are still facing east. In the J case, we're now moving north. Part 2 is hurting my brain. Well, yes, it's kind of hurting mine too. But actually, I wouldn't say hurting. Like it's stimulating my brain in a nice way. So, if this is a 7, we're now heading south. And then now, we are heading west. So if we're going west, so if we're moving west, left, the L moves us north, and F moves us south. Okay. So you got all those cases handled. Now we can do something here. So I'm going to make an assumption here. Wait, before I do, I think I just realized where my one point where we branch out into 3. Okay, my original adjacent S shouldn't appear in all of these. I should only appear in the ones that contain a j, because it is just another j, and we have just determined that. Note S is a j, right? Okay, I'm just gonna do that right now while it's in my brain so that we don't get any accidental bugs here. Um, no, it's pause that move dir. Pause that move dir. Okay, now here. Option dot when um current, or I guess next is not. So I guess we're gonna determine what's next and when it's not back at the start. Okay, so val next equals current dot move dir, and val next dir is next dir of current and dir, sure. And then the points to the left and right. Yes. Should we take that from next, or should we take it from current? I think it's fair to take it from. Let's take it from the next that we are stepping into. But then if next is start, we're not going to take that. So I think we should take it from the current because the current is the only time we're processing start. The squeeze between the pipes is what's blocking me. Well, I started an approach that does that, and I'm abandoning that approach because I think I have an easier one. We're not even gonna think about that. Like this. So my approach now is that this loop partitions every point into two areas, right? The outside and the inside. And if you walk along the loop, the outside is going to be to your left or your right. You don't know which one. But basically, if you're walking along the loop, every point that appears on your left is not going to be one of the points that appears to your right. So I'm just gonna walk the loop, get a list of the points that appear to my right, get the points that appear to my left, and then flood fill those out to all the free space, each of them. And then I'll either figure out which of these sets, the one to my right or to the left, is the outside set. Or I'll just check with both. Look at the size of one of these sets. The size of one of these sets is my answer. And I don't have to do any determination. No need to squeeze through pipes or whatever. I'm not gonna calculate any of that. And I think it's an easier approach to think about. It just takes a little time. Okay, next left spaces. Okay. So I have a rotate function on my dir. I think, okay, we start with an empty set of left spaces and right spaces. When we have our current space, we're going to end when whatever the next space is. So option dot when next is not equal to start. Yeah, and since we start at start, we should get whatever's to our left right now. The val left equals our current dir that rotate, turn left, and then we take, I'm going to rename current to pause. So pos dot move dir dot turn left. Val right equals pos dot move dir dot turn right. And these will be added to the left set and the right sets, assuming they are spaces and that they are also valid. So this is the left space or the left location, right location, and we'll do stuff with that. And next is our direction after turning, which we don't need quite yet. Let's put it in here. So when next is not equal to start. So our new state, val new state equals next pause. So we're gonna have next, nexter, less spaces, less left, if it contains, val next left. So if it's in bounds, so area dot inbounds left, and grid left is a dot, then okay, they don't know quite what type I was going for there. So this is the correct condition. Then left spaces plus left, else left spaces. Right? That's a really long line. It's correct. We refactor when we're done. Or tomorrow. This is probably a refactor tomorrow kind of deal. There we go. And then the new state is nexter, and then next left, just set points, and then next right. And then great. Oh, the state is sort of part of our output, isn't it? What are we? The state. Oh, okay, so this left and right are our output. So I think we just output. I'm gonna unfold this into. We're gonna unfold this into an iterator of tuples of points. The point to the left and the point to the right, if they exist. So like a tuple of option of points. Right? So our state will not include left spaces and right spaces. So we are returning an option tuple of an option of point and an option of point. Left and right spaces if they are spaces. And then now we don't need these sets. Let water. Okay, now we don't need these. Our state is smaller. It's just the position and direction. And this is the left point, and this is the right point. And then we will call this val left space. We can delete these. So was option dot when grid dot left is a dot, and before we do that, also check if area dot inbounds, or is it position to left dot inbounds of the area, right? No, it's area dot inbounds, or rather area dot contains. It's point dot inbounds or area dot contains. I don't know my own methods. Okay, left dot inbounds of area, and grid left is space, then we return that left. And this, so val right space equals option dot one, and right is in bounds, and right is a space. There we go, there we go. And then we return left space and right space. The left space and right space onto the new state. Great, and this is our walk, so val walk. And then val left and right equals walk dot, we're gonna unzip. Now left is an iterator of, wait, was, okay, so walk should be an iterator of tuple optional points. Are there, says there are no problems with this, it should be compiling just fine. And yet, doesn't seem to want to evaluate things. Okay, there, we have a compiler. Oh, we forgot the second parameter to unfold, which is our state. And our state is a point and a direction. Okay. Next dir, this does return a dir. Cursor value, oh, right. I'm just gonna put this right down here. Okay. Yeah, that works. That compiles now. And now we can unzip it. Is there an unzip? So walk dot un dot to list dot unzip val, and then this is left and right. And then left dot flatten dot size, right dot flatten dot size. One of those is our answer. We're gonna try them both. How about that, Eric? I am. Wait, wait, wait. Why is it so small? Is it really that? Okay. I am going to win this with a guess and check. 132. Oh, okay. I have to wait 1 minute. We'll wait 1 minute, and then we'll try 47. Okay. That cost me a minute. Too many wrong guesses before this. I mean, in the meantime, you know what? We could draw this. So, we have a drop below. Area dot draw. So we determined that left was not the inside, so left is maybe the outside. So in this case, we'll draw an O. So we have a point. If left dot flatten dot contains P, then O. Else if right dot flatten dot contains P, then I. Otherwise, you do grid P. Let's take a look at that. And oh wait, that's not promising. There are, oh wait, I forgot to flood fill. Okay, we have to flood fill those. Okay, so we'll call this like val left seeds equals left dot flatten dot to set. Val right seeds right dot flatten dot to set. Because that's wrong. And then we're gonna do val left flood. equals iterator dot unfold. We're going to do this once again. At this point, it knows exactly the algorithm I wrote. Oh, yes, it has learned my code. This is exactly how I would write it. Except I don't need this adjacent function here because we are just doing it flat map adjacent. And then this adjacent doesn't even, okay, dot filter area dot contains dot filter grid of that equals a space, just flood filling spaces. And then diff out visited. Okay. And then we're going to turn this into a method. So def flood leads as a set of points. And then the end result is also a set point. So val points is whatever. And then we're going to take points.reduce union. And then this gets us a set of point. Okay, so val left flood equals flood of the left seeds, and then val right flood. Exactly. And then now in our drawing, we're going to use left flood and right flood. We're going to assume left is O for now, and then we'll look at the picture and see if it makes sense. Left flood P, else if right flood contains P, then I. That is also not promising. But let's just take a look at it anyway. Batch. Okay, this is what I printed. There are emphatically no I's and O's. Even though these points, interesting. Let's go back to this. And left seeds, let's look at the size of these. So left seeds, dot size, left flood, dot size, and then same thing for right. IG. Okay, so I mean, those are potential answers here. Right, there are a few. I expect that there are only a few cases where flooding is necessary, just having looked at the map, right? Having looked at the one where I show the, where is it? The block Unicode. Remember this one? There aren't many places to flood. Like maybe those two there. And honestly, it could be the case that I miss places if I'm turning a corner. If I turn a corner, I should perhaps take parts more aggressively, like everything to the left and forward, and to the right and forward. Right? These would be lists of points. Yeah. Yeah, I might have to. But let's debug what we have currently. I don't know why this is not printing how I expect. Left flood. So left flood is a set of points. Some of these points should be in here. Why are they not? know. Let's say explicitly contains. I just find it so odd that it just prints the whole grid. It's like left flood doesn't contain any of those. Actually, let's do this. Left flood dot intersect, and we'll just do area dot points iterator dot to set. Right, that should be greater than 0. Okay. In fact, it should be the same size as left flood. And this draw should iterate over all the points of the area. So if that's the case, then why does this never trigger? Let's take a look at that again. So let's copy the worksheet output, go back to Scratch. Okay, so this is that. Okay, there are some O's in here. There are some O's in here. There are some I's in here. They just don't hit all the points. Okay, because not all of these points are part of the boundary. Ah. Okay, so let's just draw out the boundary bits. And again, let's take our block Unicode. I'm just gonna put that all the way at the top so that we don't, whatever. Else if boundary points contains P, then block Unicode character. And boundary points is defined way too low. Oh, it's defined up here. Okay. I think we should treat everything that's not in the boundary points as part of, yeah. Okay, let's draw this. Is there a problem with this? Double definition, block Unicode. Okay, block Unicode is defined down here too. Okay, let's take a look at this. And we have this. Okay, I think we should treat everything that's not part of this as a dot. And then from there we do our flood fill of points that are inside and outside. And then we take the intersection of the inside points. We take the intersection of the inside points with spaces. Right? Okay, so minor change here. Minor change. In our flood. So we filter that the area contains it. All right. And then we also diff boundary points. And then we diff visited. Right? That is what we flood. And then we take the intersection of that space points. So val space points equals area dot points iterator dot filter. Exactly that. Okay, let's see what the drawing gives us. Ooh, that's looking better. Oh, that's looking promising. And left is outside. Okay, this is very promising. Very promising. Oh my god. Look at that. That's beautiful. Beautiful. Um, yeah. Okay. I wonder what these points are that are not even by just printing out normally. But there are no dots there. Okay. So we are almost there. We are almost there. Now we take um, left flood dot intersect. Oh no, left flood is outside. Right flood dot intersect with space points dot size val and 2. Okay, if I were a betting man, I would say this is the answer. Let's see my bet. Oh no. Okay, okay. Um, we're close though. We are very close. Let's look back at our drawing. Look back at our drawing. Okay, there are eyes. What are these points that are not determined at all? And are there any dots in here? I'm gonna search for dots. Search for dot. Nope, there are no dots in there. So every space is accounted for either by an O or an I. But we don't really need to worry. Yeah. You don't really need to worry about these weird things here that didn't become part of anything. Um, just so close. Oh, we don't want that. Okay, so we know that right flood is inside. So base points, not size. And then right flood intersect space points, not size. And then left flood intersect space points, that size should add up to it. Right? And 526 plus 33. Do different users get different maps? Yes. Yes, they do. So for you, if you were to use my code, left flood might not be the outside. You can determine this programmatically by doing like, you know, left flood dot contains point dot origin. So, and that tells you, yes, yes, they should all look different. I don't know if it's like completely unique per user, right? Like maybe a few other users got my input. There might be like a set of inputs. I don't know how many of them, but I know chances are you don't have the same input someone else does. Um, and that might depend per problem. Some problems might be easier to generate data sets for, and some problems might require to be very carefully crafted, which is part of why Eric asked us not to commit our input to Git repos. So you should not be committing your input to Git repos. Okay, so we clearly partition the space points. 559. We tried 33. 33 is, I mean, right flood is clearly the inside. And that was off, right? 33 did not work. So we are off somewhere in our partition, but not by much. Is there a detail I'm missing? Here the tiles are enclosed. Is it every tile? Just the tiles are enclosed by the loop. Oh, how many tiles are enclosed by a loop? It doesn't matter if it's a space point or not. So it's not it's not right flood that intersects space points that size. It's just right flood that size. Um, right flood that size. That's it, just 185. Okay, I just misread that. Space points did not matter. Oh no, okay. Ah, I have to wait 5 minutes. I can't submit until 2:11. Ouch. Okay, let's look at our drawing again. Um, these are all enclosed. It could be some of these are not accounted for, right? So, right, yeah, some of these are not accounted for and need to be included. So I can expand. I can expand that. And this is how. So we were looking to the right and we were looking to the left. We can look to the right and forward and left and forward and right and backward, left and backward, and we'll still be safe. Because if those are end up being like more boundary points, then we'll like walk into that eventually, right? Yeah, it could not possibly that could not possibly be part of the left boundary if that there is right. So we're gonna go forward and backward, and I think that will account for all these other points. Um, so let's do that right here in our flood. Um, so no, it's not in flood. It's in the walk method. So this is now a list of points. All of the rest of the code should still work just fine on a list. And yeah, we're going to do a list of points. List left, and then left that move direction in the same direction we're facing, and then left that move direction dot turn left twice. Okay, there we go. And filter inbounds. And do we need to filter that's a dot? I don't think we even need to filter that's a dot anymore. I think we do need to filter that's not part of the boundary points. So, I mean, we diff that later on. I don't think we even need to do that. Right? Well, right space equals list. Exactly. Now, that should still work. Area dot size. Hold on, that's looking way too big. Area dot size is 19. Left flood dot size is way too big now. Okay. So our seeds, our left seeds and our right seeds might be too big. Okay, let's add a filter in here. Dot filter. I mean, we could add this back in, right? This is fine. Okay, it's looking more reasonable. Whoops. Let's copy that worksheet output and let's just see how it looks. Oh, oh, that changes things in a way that's not so good. Okay, so some of our assumptions are wrong. Um, oh, I wish I'd left my previous code commented. Let me see if I can recover some of that previous code. We're just going to comment those out as a reference. Right, now the only thing we're changing, I think we also diff against or filter not boundary points. We're getting more aggressive with our filters. I don't think we need this filter here. Let's try that. Oh, well, left space. Here we go. Okay, let's see what this looks like. Copy worksheet output. Okay, everything is part of a set. Okay, great, great, great. And I think the right seeds are inside right ands to what had we determined? Okay, so right flood dot size. Let's do some tests. So right flood dot size, left flood dot size, and then area dot size. Let's see these two added together. We need boundary points dot size. Let's add boundary points dot size. Okay, I have a cat. Okay, get up. Sorry about that. Um, and that's too big. That's too big. That's too many points. Hmm. So what I'm just gonna do, we're gonna do right. We're gonna do a quick guess and check. Right flood dot diff boundary points dot. Okay, let's check. Right flood dot intersect left flood dot size. That should be 0. What? Oh no, that's not good. Wait, what are we printing here? It's determined a lot of that is inside. Okay, so it is no longer. It is no longer a partition. So that's not great. Let's move some of my tests a little bit closer here. See which one contains the origin. So right flood dot contains point dot origin. Whatever contains a origin is outside. So left flood. Right, and they both contain the origin. So I mean that's not good. Base points, we no longer care about space points. We care about admin code points. That is not useful to us anymore. I think this flood here is still a reasonable function. Let's look at our left seeds and right seeds though. Oh, we have a problem. Space points. Yeah, we don't care about that anymore. Um, Minus 2 equals whatever, we don't know yet. Yeah, let's look at our seeds and see if those make sense. So left seeds dot intersect right seeds dot size, that should be 0. But it's not 0. Okay. So we look at the left, so we turn left, and it's a point to our left. Right, it's a point to our right. And somehow, when we're doing this diagonal forward and diagonal backwards, we're sometimes getting points that are in both. And how is that happening? The problem is, if we just take the right, what we could do is this here, and we just take the left. Oh, then they no longer intersect, but they don't cover everything. Right? 8 points are unaccounted for. So false is inside. Just leave that note here. The left flood dot size 5,414. It's close to that. It's not quite that, right? Or wait, actually, rather the right flood dot size 294. Wait, 294. That's not what I gave it for. Oh, I was giving it right seeds dot size, not right flood dot size. Oh, okay. That's still wrong. I shouldn't have entered that. This still doesn't add up, right? Right flood plus left flood plus the boundary should be array dot size or area dot size. Unaccounted for is this 8 points. Why don't we look at those unaccounted? Well, unaccounted equals area dot size dot diff, all of those points. Oh wait, not area dot size, but area dot diff. Or area dot points iterator dot to set dot diff. Okay. So if left flood contains, that's O, right flood, then it's I, left flood dot intersect right flood, that should be 0. That should, okay. So right now, else if unaccounted contains P, then we draw an X. Otherwise, we draw the grid, which in this case, it should not. Oh, yeah. Let's take a look at that. Where are the X's? Okay, there are a few X's. How do we account for those X's? I think we just let's just draw the boundary and see what they should be. That old code. So the unaccounted ones we'll use the blocking code now, and then we'll just use grid B. Just draw the normal pipes. Okay, so these blocks, like this one here, right? So we are moving around in here. Um, this is part of the boundary. This loops around, sure. This loops around. Hmm. So this is one case then. It's like we turn the corner and we don't catch everything. So the point that's currently ahead of you. So it's like after you turn, you should also get what's to your left there. Yeah. Or if you're going to turn right or left, then you get the point that's ahead. That's what I'm going to do. If you turn right or left, you get the point that is ahead. Um, okay, during our walk. So, this is what you do if you're just moving straight. That works. Left of your current, whatever. And then if next direction, then we have to add other bits. I'm just going to write this in a huge if else, and then we can refactor later. So if next direction is not equal to dir, then list left and oh, hold on. Next direction is where you're facing afterwards, right? So that will be accounted for because you move forward and then you're facing right and then left is out there. But the point ahead, right, where you came from, the left there. So we're going to look to the left of the point that is ahead if we are turning right. Right. We could also get this automatically, look left and ahead. And what's the case when we don't want that? We don't want that when we're turning into it, right? That's the only time when we don't want it. I don't think we need to worry about that. If we only worry about moving forward here, because we don't have to worry about if we're moving left or right, because we just filter not the boundary points, right? And then right, that move in this direction as well. And let's make sure this intersection is still 0. If this intersection is still 0, oops, then we are probably golden. Okay, how many are unaccounted? Unaccounted dot size 0. Okay, this is probably our answer then now. Um, you take a look at it. Let's spot check it. We don't want to waste another 5 minutes. So copy worksheet output. Okay, everything is accounted for. This looks good. Faults is inside. So val adds 2 is equal to, which one is false? Right blood dot size. That's at 297. We were off by 3. That's it. Got it. Got it. Okay, took too long, but I like my final solution. I like how it works. And there's potential for good cleanup there. Um, yeah, I'm happy with that. Okay. How did I do? I think, oh, in spite of it taking, this was a harder problem. In spite of it taking 2.5 hours, I was still ranked 3,000. As faster for Okay. Did I climb in any leaderboards? So I was tied for 7th on my private leaderboard. And I'm currently at 3rd place because a lot of people have given up on it on part 2. Oh, wait, no, they haven't given up. They're just still doing it. Um, I'm presently at the top of the Scala Center leaderboard until Jan Peter catches up. Jan Peter's on my leaderboard too. Oh yes, yes, from last year. Hey, I'm feeling good about that. There's a little win for me. After these last few nights, I get a little win. On Midnight Summons leaderboard, how many people have finished? So I am the okay for day 10 here. I'm the 10th to finish. There are a lot of fast people on this board. But hey, you know what? I oh did I? I didn't even get medals today. I finished, but people did come in and finish before me. Oh well. I like my solution. Um, yeah. So I'm just gonna commit that real quick. Okay, so adding day 10, and so this is a 2023 day 10 as committed as as solved on stream. And again, if you're interested in seeing that solution, I'm going to clean it up. So you have until, I don't know, tomorrow night's stream to see the messiness in all its glory. But the GitHub is here. On YouTube, all these links I'm dropping are just in the description. And if you want to join the leaderboard, here's my code. And if you want to share your solution, I'd very much like to see how other people approach this. This is an interesting problem. You can share it in my Discord here, and I'd be happy to chat about it. I'm going to review everything that gets in there. Okay, so that's enough of that. It is late, so I'm not going to clean this up right now. But I think this approach will clean up very nicely. Um, so tune in for that tomorrow if you're curious to see how that happens. I'll show up a little bit before tomorrow night's Advent of Code drops, and let's find someone to raid. Twitch Advent of Code. While we're at it. Oh my god, doing this in Bash, that's gonna be a nightmare. Alka is on, and I don't believe Alka has finished. Right? Okay. Hey. I got Alka for once. Um Yeah, let's go join Alka.
The path right.
They are good at this. They also
Like
do
it.
a lot of creative
So
programming,
now
and
I could go
you know, sometimes they'll do visualizations for Adma code. He might be using
right.
visualizations to help
Is
himself
this
solve this.
tile dot
But we're reading Alka.
connected neighbors
Read Alka.
to the east exists. So this will be a
Alright.
tile
Well,
or null.
thank you everyone for joining.
So does not equal
Have a good night,
null.
and good luck with the rest of admin code.
And the
Let's
path
see how Alka does this.
below is a connection if the one to the south, which is 2, is not null.